Grade 11 pre-cal, lesson 55, quadratic inequalities in two variables. So this is similar to when we did it with just one variable, right? Remember the number line back there where we just did everything on the x-axis. But now we're going back to y. So we're kind of taking everything and plugging it in together. So what we have here is we have, if you look, we have a quadratic. Now this is in vertex form, which is really quite nice. So if you look at the vertex, right, you can see the vertex is, what number do you plug in here? 3 and then positive 1. So there's our vertex there. Determine if the point 2, negative 4 is a solution to the inequality. A couple things. So first off, you see that it's less than, so you know it's a dotted line. This is a quadratic. You can work through and find the x-intercepts, but this is just general shapes. You can see right there, there's our quadratic dotted line. Where do we shade? Well, again, you pick a test point. So in this case, I picked 3, negative 3, 3, negative 3. So somewhere in the middle, hopefully, of this. So we plug it in. We've figured out, yeah, negative 3 is less than 1, so it's true. So we shade inside the parabola. Now, if it was false, where would we shade? Well, we would shade all on the outside here. So look at the original question. So is 2, negative 4 a solution? You could plug it in, or you could look at it graphically. It doesn't matter. We plugged it in here, so negative 4 less than negative 1. Yes, that's true, so it is a solution. So you can see that. So all we're doing is we're taking all the concepts we've learned so far and apply them to parabolas, basically. Okay, go to the second example here. So let's graph this one. Now, this is in standard form. X squared minus 4x minus 5. So first off, you know right away, hey, negative 5, that's the y-intercept. Yeah, there it is. Hey, it's greater than or equal to, so it's going to be a solid line. How do we find the vertex? There's multiple ways to find the vertex. You could use negative b over 2a. You could find the x-intercepts and then find halfway in between. Guess what we do? We're going to complete the square because you always need practice on completing the square. So to do that, you know, put our brackets around, move the negative 5 over. Okay, we take the negative 4, we divide it by 2, and we square it. So we end up with negative 2 squared, which is positive 4. So we're going to add 4 on the inside. But remember, what do you do over here? You subtract 4. Okay, so we do that. We end up with x minus 2, right, where we got that negative 2 there, minus 2 squared, and then minus 9. So what's the vertex? 2, right? What number do you plug in there to make it 0? 2, comma, negative 9. Yeah, there it is, 2, negative 9. Hey, do you want to find the x-intercept? Sure. This one factors lovely. So we take the trinomial, we factor it into two binomials. There that is. So x is 5 and x is negative 1. So there's our negative 1, there's our 5. So we can actually graph the whole thing. Solid line because it's greater than or equal to. Pick a test point. What are you going to pick? 0, 0. Hey, it's a nice, easy test point. 0, 0 is often easy to work with because you can do the math without a calculator. So plug it in. We find out 0 is greater than negative 5. Is that true? Yes, it is. It's true, so we shade that area. If it was false, we would shade on the outside. Okay, now the last example, the third one here, is a real life example. So what this is a parabolic reflector, and they use this in sports. You'll often see them like in a football game. These people will be standing on the side with these big, looks like salad bowl with the earphones on. And basically what they're doing is they're picking up what people say on the field. So it's a big disc, and if you want to draw a picture there, we can draw a picture of what it looks like. So it gives us a couple things. It says the reflector has a width of 50 centimeters and a maximum depth of 15. So if we graph this, there it is in quadrant 1 and 2. If it's a width of 50, then we know this point is 25, depth of 15. This one is negative 25, depth of 15. So we can figure out the 2 points. So we get an actual parabola like this. Well, describe it graphically. Well, what does a normal quadratic look like? If the vertex is 0, 0, a quadratic would look like y equals ax squared. That's it. So all we worry about here at case is a. Is it positive? Is it negative? Right? Well, it opens up. So what is it? Positive. If it's open down, it'd be negative. So we know that. It's probably pretty wide. So it's probably going to be a fraction and not a number like 2, 3, or 4, right? Because that would make it really narrow. So all we do is we substitute values, and you pick whatever point you want. Negative 25, 15, or 25, 15. So we plug in 25, 15. We plug it in and we do 15 and the 25 here. We work through it, right? 25 squared, 625. So we 15 over 625, reduce it down to 3 over 125. Like I said, it's probably going to be a fraction. So there is our equation. So then we pick a test point to help us with the inequality. So pick a test point. So you could pick anything within here because this is what it is this part is shaded because that's the part that picks up the sound, right? The sound actually comes in this direction, right? Bounces off here and actually comes to a center microphone in the center. We don't have it drawn that way. So, right, the sound comes in, bounces to a center microphone. So it's shaded in the middle. So pick a test point, we pick 5, 5. So plug in the numbers 5 and 5. How do you make this true? 5 has to be greater than or equal to, right? solid line, it picks up sound on there. So it's greater than or equal to. So there is our equation. Y is greater than or equal to 3 over 125 x squared. But it has some restrictions. X has to be between negative 25 and positive 25. Because these are very, very directional, right? If the sound was coming in here, I'll just draw it. If the sound was over here, it wouldn't pick it up, right? The sound has to be within the parabolic reflector, anywhere coming in here, right? Anywhere within here. So it has very distinct. So if you ever watch these guys, they're always pointing it right at the person who's speaking so then they can pick up the sound. So there's another real world example of using quadratics and using inequalities to figure out things when it comes to sound. There you go.